Hi, our team is conformed by Carlos del Rosario and Daniel Villafranco. We're going to talk about our key activities, weight against distance.
Okay, so to introduce you a little bit of what we are going to make, we decided to make an experiment in order to determine if the weight of an object affects the distance or the range that it can travel when it's thrown by a catapult that uses the same force for every object from a fixed point.
Um, this experiment will help us to realize if the weight of an object affects the distance of the object. It can help us to know if it is easier to throw an object that it is lighter than an object that is heavier. To know how much distance is an object can travel when it is thrown, to know how far we can lift or throw an object with a backhoe, for example, and to determine how important it is to change the launching force depending on what the object weighs.
For the theoretical framework of this experiment, we used a topic that is projectile motion that we learn in Physics 1 in fifth semester. Um, with this topic, we learned that the projectile motion is defined as the motion that an object that is thrown or projected into the air have. We are having two different variables, the weight of the object that is going to be thrown as our independent variable. Every object has a different weight, which will mean that no object would likely be thrown and fall in the exact place in comparison to the other objects, which lead us to our dependent variable, which is the distance any object can reach when thrown. According to the theory, the relationship between weight and range is consequent since the more weight an object has affect the range the object will finally reach. And longer the range achieved can explain as the consequence of a lower weight an object carries while being thrown, whether temperature are other variables that indeed affect the range of an object. On the other hand, we have air resistance, launching angle, launching velocity, materials used to as control variables. The control variables mentioned before are going to remain constant and exactly the same for all experiments. This means that there's not going to be an external factor that we cannot control affecting our experiment development.
The next section is methodology, which is about the studied variables, the materials, and the method. The studied variables, as my partner said, we have first the independent variable, that is weight of the object that is going to be thrown. The dependent variable is the distance the object can reach when thrown. And finally, the control variables are air resistance, launching angle, and launching velocity, and the materials used.
So the materials we used were 24 wooden tongue depressors, 5 rubber bands, 1 plastic bottle cap, 3 staples and stapler, flexometer, post-its, a pen, a cutter, 5 or 6 objects with different weights, and a camera or the phone camera.
Okay, the method is divided in two sections. The first is to make the catapult. The first step is to take 6 of the 24 tongue depressors and make marks with a pen at the two ends of the tip. Then cut into the marks with a cutter that make passings in 6 tongue depressors and put them aside. Join the 18 tongue depressors that we have left, and join one of their ends with a rubber band. And it has to be tight. Put 3 of the tongue depressors that we cut at the beginning between the last and the penultimate tongue depressor of the 18 that we put together. Join the other ends of the 18 tongue depressor so that the three lenguas that we inserted between the last and the penultimate of 18 are tightened.
Then we're gonna join the three tongue depressors that we have left loose with a rubber band, so they are well united. Then we're going to join the teeth with socket. So the six tongue depressors that we cut at the beginning, and we tighten them with a rubber band. We attach the three remaining joint tongue depressors and on the 18 that we were left together so that there is an angle. We staple a plastic bottle cap with three staples to the other end of the three tongue depressors that remain joined so it doesn't move. We put a rubber between the 18 tongue depressors and the tips with the sockets to reinforce the catapult. And with that, the catapult is ready to perform the experiments.
The second section consists on the development of the experiment and data collection. First, we have to put the catapult in a fixed point from where we are going to launch each of the 5 or 6 objects. Record in a table the 5 or 6 objects with their names and their different weights. Start recording with the camera or phone. Take an object and place it in the bottle cap that is in the catapult we made. Pull the catapult and release the catapult in order to launch the object. Mark with a post-it the point where the object fell to know the distance it traveled. Repeat steps 4 to 7 for each of the objects. With the help of a flexometer, we measure the distance between the catapult and the different marks we made with the post-it to measure the distance the objects traveled. We have to stop the recording and review the recording to verify that the information obtained is correct. Record each of the distances of the objects in the table where we had put their names and had their different weights. And finally, analyze the information obtained to be able to get conclusions.
And the next part is the results. The data obtained, as we can see, is that depending of the weight of the object, as heavier it was less the distance that it traveled. As we can see in this graph, we can see that in the bottom part, we have the weight of the object, and in the side part, we have the distance that it traveled. So as we can see from this trend line, analyzing, we see that it tends to, the distance goes down when the weight of the object increase. So analyzing all the data, we obtained that from the experiment and the trend line represented in the graph, we obtained that the equation of the trend line is y equals to minus 0.0686x plus 3.0804. And if we analyze it, we can realize that referring to x as the weight, the bigger the x is, the smaller the y turns, which let us know that as higher that is the weight of an object, it will be less the distance it is going to travel.
Finally, our conclusions. As our conclusions, we can say that it is correct that the fact that the heavier an object is that will be launched with the same catapult or by the device that can always do it with the same force or speed, the less it will be the distance it will travel. Our areas of improvement are the following. You can try to do the experiment with more objects for a more accurate result. You can also do it in a larger environment with all variables controlled. And finally, you can do it with the help of more people to have support to corroborate the results and also to have different points of view.
So that was all about our experiment, and this is our references, and thank you for your attention.